The sine and cosine trigonometric ratios. What is the sine ratio? The sine ratio is a ratio between the hypotenuse and the opposite side of a given angle in a right triangle. What is the sine ratio? Here it is in diagram form. A right angle triangle labeled ACB, with C being the right angle, the hypotenuse, which is opposite the right angle, theta, our reference angle, and across from theta, the opposite side. The sine ratio is a comparison of the opposite side relative to the hypotenuse. Here, the sine ratio is given as a formula. The sine of theta, which represents the reference angle, is equal to the opposite side divided by the hypotenuse, which is, of course, our ratio. When is the sine ratio used? If you are given a right-angled triangle, label the three corners. A reference angle, theta, in our case it's angle B, the length of the hypotenuse, and the length of the side opposite the reference angle. Draw across the opposite. The formula then, sine theta is opposite divided by hypotenuse. The COS ratio. What is the COS ratio? The COS ratio is a ratio between the hypotenuse and the adjacent side of a given angle in a right triangle. What is the COS ratio? Here is a diagram to show you. Triangle ABC, right angled, theta, angle B, the hypotenuse across from the right angle, and adjacent, the side right next to the reference angle. What is the COS ratio? Here it is in ratio form. COS theta is equal to adjacent divided by hypotenuse, which of course gives you a ratio. When is the COS ratio used? If you're given a right-angled triangle, a reference angle, in our example it's angle B, the length of the hypotenuse, the length of the side adjacent to the reference angle, you could use the formula COS theta is equal to adjacent divided by the hypotenuse. Here's example 1. Given triangle ACB, side AC is 9 centimeters and side CB is 12 centimeters. Angle C is 90 degrees. You are required to find the sine and cosine ratios for angle B. Now, just to remind ourselves, the sine of theta is opposite over hypotenuse. The cos of theta is adjacent over hypotenuse. Now, here is our solution. Our diagram, our formulas. Since both formulas require the length of the hypotenuse, start by finding the length of the hypotenuse. Hypotenuse squared is equal to the length of AC squared plus the length of CB squared. This is using the Pythagorean theorem. The length of AC is 9. The length of CB is 12. We will substitute those values into the equation. We'll do our calculations. 9 squared is 81. 12 squared is 144, which will give us a value of 225. Therefore, the hypotenuse would be 15 centimeters in length. From there, find the sine of angle B. Sine of B is opposite over hypotenuse. Opposite theta has a value of 9. The hypotenuse has a value of 15, which will give us, in lowest terms, the ratio 3/5. Find the cos of angle B. The cos of B is adjacent over hypotenuse. Adjacent is 12, hypotenuse is 15. In lowest terms, this would be 4/5. Now, visit the video Problems using the sine and cos trigonometric ratios.